In this example, we are given that a figure shows a cylinder on which a string is wrapped and the other end of which is connected to the hanging mass small m. And it says if cylinder moves in pure rolling, we are required to find the acceleration of this falling mass. Let us consider the mass is falling down with an acceleration a1 and the cylinder is moving forward with an acceleration a2. And as it is rolling, let us consider its angular acceleration as alpha. In this situation, for pure rolling, we can write here a2 must be equal to r alpha, as a2 is the linear acceleration and alpha is the angular acceleration. And for pure rolling, we can state a2 is equals to r alpha. Now, using these parameters, we can also develop a constant relationship between a1 and a2. As the cylinder is moving forward with a2, the string will also unroll with the linear acceleration r alpha. So, the string points will move forward with an acceleration a2 plus r alpha. So, we can write the acceleration of falling mass a1 can be written as a2 plus r alpha. So, in this situation, this a1 can be written as 2a2. Now, we can very easily develop the equation of motion of both of these bodies, and we just solve these equations. Like in this situation, if we consider the tension in a string to be T, for pure rolling, let us consider the friction, a static friction which is acting on cylinder would be F. So, in this situation, we can write for this mass M, if we write equation of motions for block M as it is falling down with A1, we'll write its equation as mg minus T is equals to M1. And for the cylinder which is moving forward with A2, its equation can be written as T minus F is equals to MA2. And the acceleration A2 we can write here as A1 by 2. So, it will be 2m into A1 by 2 as the mass of the cylinder is 2m. Now, along with the translatory motion equation of bodies, we can also write the equation of rotational motion for the cylinder. And for its clockwise motion, it is experiencing a torque due to tension in string as well as this friction. And both of these torques, you can say these are clockwise. So, its rotational equation of motion can be written as TR plus FR is equals to I alpha. For a cylinder, its moment of inertia can be written as half mass of cylinder into R square, and its angular acceleration can be written as A2 by R, which can be written as A1 by 2R. So, in this situation, this R gets cancelled out. This 2 also gets cancelled out, and from these three equations we can easily solve and get the value of A1, which is the acceleration of falling mass. Here if we add these two equations, you can see what we are getting here. Friction gets cancelled out. This will be 2T is equals to, this is MA1 plus MA1 by 2. So, this can be written as 2T is equals to 3 by 2 MA1. Now, in this situation as 2T is equals to MA1 plus MA1 by 2, it is 3 by 2 MA1. So, this gives us 4T is equals to 3 MA1. From here, if we substitute the value of tension in equation 1, see what we'll be getting. Here we can write from equation 1, it is mg minus, instead of tension we can substitute 3MA1 by 4 is equals to MA1. So, on solving this equation, we'll be getting, you just take this term on the right side of equality, it will be 3 by 4 plus 1. It is 7 by 4 MA1 is equals to mg. Here m we can cancel, and solving this will get the value of acceleration A1, which is that of falling mass, is 4g by 7. That will be the answer to this problem.